Hey everybody, Mr. Hayes here. Welcome back. We are doing StatsMedic. We are in the last section of Unit 6. We're going to be talking about power today, and then we only have 3 more units left. Unit 7, everything we've already done, we're going to do with means. The last 2, chi-squareds, a little bit of regression, both short units. Then we start reviewing. It's going to be exciting. Now, what we're doing today, the notes are down below from StatsMedic. I have a link there. I also have a link to the website we're going to be using down there. While you're down there, comment, like, subscribe, leave your favorite ice cream flavor. Doesn't matter. We'll talk to you soon. I feel like I'm just ending it. Let's jump into the notes. I'm getting a little too excited here. So here are the notes. We're doing the basketball thing again. And you know, it's a good thing to go back to. It's going to kind of build back. And it's almost like we're trying to come back to the same idea and building upon it. That's because we are. So last time, I promise, until it's not, but I'm pretty sure this is the last time we see it. So I'm a free throw shooter. I'm saying I hit 80%. We actually end up going down here. You guys are skeptical. You think I less than shoot at 80%. I shoot. And I hit, I think it was 67% before. So write in appropriate hypotheses for these significance tests. Be sure to define the parameter of interest. So P, the parameter, is the true proportion of made free throws by me, Mr. Hayes. I've got the dog on the screen. Oh, well, the dog will be fine. Null hypothesis, probability is 80%. In other words, I'm being truthful. And if you remember from before, the alternative hypothesis is that I'm shooting less than 80%. So I'm exaggerating under the best case scenario, right? So now the next thing they go through is describe the type 2 error. And we did the box last time, talking about the type 2 error. And if you remember correctly, the type 2 error means that the alternative hypothesis is true, but we don't have enough evidence to prove that it's wrong. So this is saying that I am indeed a less than 80% free throw shooter, but we fail to reject the null hypothesis because we don't have enough evidence for it yet. Okay? So we're going to talk through that. So let's go through and say, let's say my free throw percentage is actually 66%. We're going to talk about that what we're seeing, that 66% is actually true. And this is where we come over here. You know what? I'm going to get rid of him. I'm also going to do this, because you guys deserve to be able to see the whole screen. And all right, so what we're going to be doing here is the following. First of all, we need to get things set up. So I'm going to, our null hypothesis is 80%. We are going to do, we think it's less than. The alternative hypothesis is less than, so we need to make sure we do that. We're going to say the true value of pi, or it can be not pi. Can you tell what I'm doing in other classes? Is 6.6 plus pi days on Friday, so, or actually on Sunday. 50 and then type 2. Okay, so the directions then go say display the type 2 error. Boom. There we go. Now, if you look at this, what ends up happening, just real quick, this red curve is assuming that that our null hypothesis is true. So that is where the center is. That's our mean. The blue one is saying, okay, that is what's actually going on. So that's why it's centered at 0.66. All right. And then the power, if we look up here at the top, so it says the type 2 error is 24% and the power is 76. What is the power? Glad you asked. Let's talk about that. So if we jump back over here, the type 2 error here, so if the alternative hypothesis is true, what is the probability of a type 2 error exists? In other words, a bad decision. It's 24%, 0.24. Okay, so there's a 0.24 probability that I am actually less than an 80% free throw shooter, but we don't have evidence to say that I'm not an 80% free throw shooter. Okay. Power. So this is the probability of what a good decision is. That's 76%. So notice what I'm doing here. Type 1 or type 2 error plus the power is equal to 1. So if this is the bad decision, everything left over must be the good decision. So what the power tells you is what are your chances of getting the right answer. Okay, so that so in this case here, if we are really off, we have a 76% chance, a probability of 0.76, that we will find evidence that I'm exaggerating. All right, so let's move on. So again, interpret this probability if this good decision. I think I just said that. If Mr. Hayes is a 66% free throw shooter, there is a 0.76 probability that we decide correctly that he was exaggerating. So we have a 0.76 or 0.76 probability that we're going to reject the null hypothesis. And a 24% chance, the type 2 error, that we're not going to have enough evidence to do it. Okay? Now, we're going to go back to the video. And now we're going to click power. And when I click on power, notice it is everything else in the graph. Okay? Now, the question here then is, how do I increase that? So you would play around with your sample size. So if I make my sample size bigger, what happens to our power? Let's double it to 100. Okay, 101, that works. Notice my power up here is now 94%. So we went from 76% to 94%. Why would that be? What does sample size directly affect? It directly affects your standard deviation. And remember, we talked about if the sample size goes up, the curve gets more narrow. If you look at the graphs here, let's say if I make it down to 25, cut it in half, notice how much bigger and wider these curves are. Okay, so the bigger I get, the more narrow it gets. Okay, so that's going to be the plus side there. I'm going to put that back here at 50. I did 50 shots, yeah. Okay. Now, what happens if I mess with the alpha level? If I mess with the alpha level, if I make it to 10%, what happens to my power? It goes up. Now, what's the downside? So we're going to make, so if the alternative hypothesis is true, by increasing the alpha value, we're going to be more likely to reject the null hypothesis, which then would also allow us to say, all right, well, that makes sense. So if we're rejecting the null hypothesis, we're more likely to do the right thing, so our probability goes up. Now, what's the downside of that? Well, the downside of that is then you also are running the risk of you're increasing your type 1 error. Okay, remember the type 1 error is that the null hypothesis is true and we end up rejecting it. So bringing that down, let's say if we bring that down to 0.1, that drops our power here. So ideally, in the back of my head, I'm thinking what we want to do is if we can increase the sample size, let's just say if we double the sample size, notice the power is up to 84%. So that's even down with a 1% alpha. Okay, so if you can kind of do so if you want to reduce the type 1 error, and in this case reduce the type 2 error, the best thing to do is increase your sample size. Now, how does this impact what the notes are saying? Good question. Glad you asked. So, sample size, went and increased the sample size, reduced the variability, decreases the overlap. Okay, the overlap is one of those things. I think I just missed one, didn't I? Alpha level increases, makes it easier to reject the null hypothesis. And last one, alternative P. So let's go back. So if I have a different p-value, okay, so let's say it's actually let's say I was only a 50% shooter. Notice it slides that mean down, that proportion gets further away from what my alternative hypothesis is. And so because of that, what ends up happening is that there's less and less overlap. That makes sense. The harder part then obviously is this: how much can we control what the actual alternative p-value is? The only other potential would be, what happens if I said I was a 90% free throw shooter? But in reality, that's probably the hardest thing to actually affect. So it is still good to know. Don't worry about that, because they're going to say, what happens if the way that I would write the question would be what happens if, it's not really a point, he didn't shoot 66% of his free throws, he only shot 50% of his free throws, and then that would be the way you could deal with that. So if I decrease P, it increases the distance from the null hypothesis. And again, here the overlap is where the type 2 error is, because this is what's actually going on. This is what we think is going on. So to increase your power, you can raise your N value, you can increase your alpha value, and you can increase the distance from the null hypothesis. So those are going to be the 3 ways we can affect the power. All right? So with that, we're going to formalize the last part of Chapter 6. Hopefully we won't hear about me shooting free throws ever again, and we'll see you on the other side.